Hello. I'm really happy to be here to talk about our all least favorite topic about technical debt. So tech debt or technical debt if you expand it to the full version. When we are talking about technical debt, we are talking about problems in software, problems that are deep and problems that are here to stay. And those kind of problems, there are many variations, and we define many of these variations as technical debt. Let's pick up two examples, outdated dependencies. You have your Ruby project, and you might have one or more than one Ruby gems that you didn't update for a while. That is a problem, because you are missing out new features for this Ruby gem. But it's not just the new features. The more you lag behind, the less attractive your software is getting for other developers to contribute, to collaborate with you. Worse than that, you might miss with these outdated dependencies, you might miss some bug fixes. And in the very worst case, you might even miss out some security updates. And for sure, that's going to get a bigger issue for you. We're also talking about tech debt whenever we see legacy code. And that's an interesting thing. A lot of people will come to you and say, yeah, we made a bad decision in the past. And this is kind of like how they see legacy code. The thing is, many times it's not an actual bad decision in the past. It's just a decision that you took in the past. You likely put a lot of effort into finding the right solution there. Finding a solution for a problem that you have there, you have your resources, you did analysis, you did research, you find like different options and you evaluated what is the best option for my problem at hand. And with this knowledge, experience that you had, you made a decision. But we know software is always changing. It constantly changes, and over time, this decision made in the past may no longer fit your current business needs. And then you look at the legacy code and say like, I want to zoom in on technical debt, on one specific part of it, about debt. Debt means that I owe something to someone else, to some other party. For instance, if I want to buy a house, I need some money, I get to a bank, I get some money from them, and then I owe some money back to the bank. I'm in debt to that bank. And this is something that I really dislike about the term technical debt, because I didn't do a thing, but still there is a technical debt, and I don't know why I owe something to that software. However, I have a dear colleague, Martin, and we had a discussion, and he changed my mind. He changed my opinion about the term technical debt, because he said he really likes the term debt in there, because debt means, or usually comes with that there is an interest on this. That means if you don't take care, it's going to get bigger. It's starting to increase. I put this in a graphic. So at a certain point in time, here marked with an X, you see that we're having some technical debt. And over time, the longer you wait, the bigger this technical debt is growing. That's a process that is very common with debt. And this is very true for technical debt. Just think of the outdated dependencies. If I don't take care for the outdated dependency, the longer I wait, the more versions will come of this. The harder it will get to update. The more interface changes might be there. And also a dependency has dependencies itself. That means, okay, it's growing over time. Same with legacy code. The longer I wait to change something there, the more integrated it will be in my software, the more often I will use it. Interestingly, looking into literature, looking into several books, you will find alternative names for technical debt. There's one in particular that is software rot. This is something I like because that means software is rotting away if you don't do anything against it. It also means it's rotting, it's spreading, and it's getting more and more. That's a nice term because it also tells it's a natural process. You can't do anything against it, you can only fight the rot, but you cannot, you are not responsible that it happens in the first place. When doing some research for this talk, I also stumbled upon another very interesting term for describing technical debt, which is more generic. It is business risk. Just like, it kind of like describes the impact that it has. Here, think about, again, outdated dependencies. If we have security patches that we miss, we are putting our software at risk. Well, at this point, you might wonder why I'm telling you all of this. So let me quickly introduce myself. My name is Christoph, and I work in professional software development for about 20 years. Had some more years in academia. And my field of interest is very broad. So in the past, I did a lot of time in web development, in front end, in back end. Did a lot of DevOps, I built a lot of CLI tools, and I even spent some years in management. And they are in very different fields, in very different companies, in very many projects that I was working, I could always find some types of technical debt. And I want to share with you how I, over the years, approached them and how I figured out a common way that I'm following. I'm currently employed at Meister, which is a Ruby company in the middle of Europe, in Austria, who are also is coming up for my travels for this very nice conference. I'm working there as a staff engineer. I also want to share one detail about Meister that I find very interesting. Meister was first published in 2007. It has a Ruby on Rails stack. 2007 means it is on a very close time to when Shopify was first published in 2006 and GitHub was published in 2008. And I found this really, really nice that we have these kind of companies that are around for such a long time, sharing their experience and also like still being very successful in production. But now let's switch to a practical example that we can use and go forward with tackling tech debt. So imagine a situation where you join a Ruby project as a developer. If you are like me, you will likely go to the project and first want to get an overview. So these are the steps that I commonly take. I open up the README file. That is one of the most important things that a project can have. I want to read an introduction that tells me, like, why does this project exist? It should be kind of like an elevator pitch that tells me some details, what's the purpose of this thing. Likely it also should contain a usage section and a setup section. These kind of things, I don't need to execute anything, I just want to see it. And just by looking at the setup section, I can tell you if there are any problems with like how it is built. The next thing that I go for is the gem file. Dependencies are super important. I want to understand, are there many dependencies? Are there a few dependencies? Best case, are there no dependencies? That's something that you can get a feeling about. Also, like working in the Ruby environment, you know a lot of public gems, so you get a feeling like, what is the base of this project? After getting an idea of the gem file, I will switch to tests. The test suite is something that is important to me. I want to understand how hard is it to maintain this project? Is it easy to add a new test? Just getting a feeling. I don't want to spend hours there. Also with the tests, I consider them kind of like the first customer of the application. After that, I've seen the tests. Now I also want to see the code because they are interplaying with each other. But again, I just want to get an idea. I don't want to execute anything, just like seeing how the style is. After that, there is one thing that I learned in the past: run the test suite. Because like joining a project and figuring out later that the test suite doesn't even pass is not a nice thing. Luckily, in our case, let's say there's a continuous integration set up. very nice. We can see it, if it is stable, we see all green, all good. Then let's say when looking at the gem file, I figured, okay, there's Robocop. Robocop as a dependency in the project, so let's run Robocop, and it fails. Okay. Well, if you don't know Robocop, Robocop is a static code analyzer, a thing that is kind of like a linter for best practices in the Ruby community. For sure, it is opinionated for a specific style guide, but it comes with a lot of benefits. And I really like to have Robocop around. Like I use it for many years. It's a very nice thing to have in the Ruby community. And it ensures that the code that we are writing is actually how it should look, how some people in the Ruby community think this is a good approach, this is good style. Okay, so we are in a situation that Robocop doesn't pass. That's bad. Luckily, Robocop comes with one feature that you can utilize in this kind of situation. You can generate a to-do file, which is basically Robocop has rules that it goes through your code and will apply these rules and see, do you have any violations there? And it will give you feedback of these violations. And you can generate a to-do file that contains all of the violation and tells Robocop, okay, next time exclude it. Let's run this. After we run it, it will create a new file that is called Robocop to do. It looks something like this. It contains things to exclude. First, it always starts with a comment that says offense count, how many offenses do I have, then the specific rule, which is called cop, and then exclude and a list of files. Here we have a team file that is included for duplicated branch cop, and another of 8 offenses in 2 files for having 2 lengthy methods. Great. Robocop is passing. Nice. Let's proceed. There's one thing. We still have this Robocop to-do file. And this is actually kind of like a legacy in our code base. This is TechTab. We know if we want to follow Robocop and have a clean, nice Ruby style in there, then we don't want to have to-dos. We want to get rid of them. So just running this Unix command, word count, and counting the lines, I received like the total number of lines that this file contains. And I see, oh, it has 1,000 lines. That means to me, okay, if it would have been 10, I just go there and fix it. If it's 1,000, I know roughly, let's say, likely it will take me days, maybe a week, maybe 2 weeks, but maybe not longer. It's just 1,000 violations. But still, it leaves us back. How can we get rid of this tech debt? How can we get rid of these to-dos? And this is where I want to introduce you to a 4-steps framework. A key ingredient to this framework is simplicity. TechTab is very tricky. TechTab is very complicated. We need something that is very simple to use and very easy to understand. The very first step that we are executing is we are getting numbers, which is a cool thing because we already did it. We run word count on the to-do file alone, and we get an idea of how much work do we need to tackle. For sure, we have no real numbers. We don't know which specific rules are failing, which violations. But software development is always about guessing. We are guessing how long it will take. We are estimating, which is guessing again. Okay, I'm fine with having just a number of lines. That's good. But let's have a look again on the file. Actually, there's a low-hanging fruit there. It says offense count in front of every rule. That means if I want to, for example, take an approach where I go fixing things rule by rule, it might be handy to know how many rules we are violating. So we can just make a trick here and just search for the offense count in the file and count them again. So this is exactly what I'm doing again here. Again, using some Unix tool because I'm lazy and I don't want to script around because it should be simple. And this simple command is the fastest way I could think of. So I use grep, and this uses the search string and will output me every line where this occurs. That means the only thing that I need to do then is counting the number of lines that I'm having to come up with the exact number of how many rules we are violating. Cool, we have 2 metrics. At this point, like you see, there is also offense counts 1, 4, 2, 28. Okay, that's something we also might consider because it's already there. Let's just sum it up and we have the total number of violations. Again, using grep, having the same output, and then forwarding it to some simple Ruby statement. As I said, simplicity. This is a 2-line command. This is very easy to run. We are forwarding the output that we have seen previously to just summarize it, to take the last word of it, convert it to an integer, and summarize it. I'm happy. The get the numbers is done for me. Well, almost done, because I also want to keep this information, because just looking at it doesn't give me a lot, so I want to store them away. We are striving for sure, introducing a database for this. Here is one conflict. A database isn't simple. We only want to strive for a database because we can be more creative. We can query, we can generate statistics, but simplicity is somehow a counterpart of it. We don't want to query. We don't need exact statistics. What we want is like having on a regular basis the information of how is our to-do file going. So instead of introducing a database and figuring out where do we instantiate it, where is the infrastructure where we run it, and how do we handle credentials, I would suggest to just create a file. And for me, just knowing how big this to-do file is, I'm fine with if there's the information every day. That's good for me. I would say it's enough if you run this on your local computer once a day, which is something we want to automate. Maybe you have a machine in your local environment that runs the whole time. You can do it there. But for this project, we have seen already there's a CI. So let's just put it in a CI and ship it away in any cloud bucket to just receive it at a later point. For this, it's fine if we do this on release, which means every time something is pushed to production, we know how big of our tech debt is at this stage. Also, if I release multiple times per day, I just overwrite the file, because I just want to have one statistic per day. To come up with such a task, it can be as simple as this. Here I was lazy again, put in the Unix shell command and just ripping the number out of there, putting it into a JSON format and storing it with the current date. You will come up, looking at all the 3 metrics, you will come up with something like this. So we have the current date, we have a JSON format, we have the 3 informations that we extracted from the to-do file. We have the total number of lines of the to-do file that we need to tackle, the tech debt stack, we have the rules that we violate, and we have the total number of violations, which also gives us an impression of how much work it will be. Good, that's now we are really finished with the first step. Now let's come to the second step. We have the number and we have the number in a historical way. What I want to receive there is I want to see how we are doing. So let's reuse the visualization that we already came up with. It perfectly fits because it has time in there. And the only thing that I want to do, I want to keep it simple. I want to have a chart that everyone can understand. So let's take this and take, for example, the total number of lines of the file, which would define our initial point, so X. And let's say we are never going to change anything in the project. That means we will come up with such a thing. So the file is the total number of lines never changes. Good enough representation of what we are doing. What we want to achieve with this is we are striving for getting rid of the to-dos. That means the total number will get lower, 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 lower until we reach 0. This is known as a burn down chart. We are taking our tech debt and we are burning it down until we reach our goal of having 0 violations. That's good enough. I want to keep it simple. Now we have 2 things. We are getting numbers. We are getting an idea of how much of a tech debt do we have. We have a second part of it. We understand how much is left of, or how are we doing with it? How much did change in the last months for tackling this tech debt? But why are we doing this? This is what our first step should make clear. We need to have a vision. If we get rid of the whole to-do violations, where are we at? Why are we doing this? What is the purpose of using Rubocop in first place? So this is something we can look up with Rubocop because it tells us we are following good practice, at least the good practice that Rubocop promises. That's nice, but what does it actually mean? So let's dig deeper into Rubocop. So if we are following a Ruby style guide, we are following one practice. That's one benefit because we also learn like how things should be styled. And with this, we create something that everything in our code will kind of like look the same, which improves readability because if you understand one part, you can read another part as well, which also comes with consistency. That is a great thing to have if you have multiple people working on a project. Because that fosters collaboration. People can work together, they speak the same language because they write the same language and read it whole day. And for some part, it's also improving maintainability. Additionally, Rubocop comes with certain sets of rules that also promise to give you feedback about the quality of the code. We have seen the method length. If it's really lengthy method, that's kind of like not good software quality. So it reduces the complexity there, or at least it tells you how to reduce or where to reduce complexity. And there are some plugins or even Rubocop, standard Rubocop cops that might hint you on performance or security issue. I say might because that's not necessarily need to happen, but it could. And that's a good thing. That's all benefits that we are gaining. To combine all of this, that basically means when I run Rubocop and we don't have any violations, so in 1 year from now, in 2 years from now, when these 1,000 violations are gone, we will have a better time because we will have less problems to a degree. And having less problems, having a higher software quality also means that we have easier changes to do. If code complexity is reduced, we will certainly be more efficient and more productive. That's it for me. I'm fine with this vision as well, because that makes us understand why we are doing this. And that's also a vision that I can share with a team, with more developers. The last thing that we need to do in this 4-step framework is to make steps towards this vision. Because we now understand that the amount of work that we are having, we understand how we are doing, we understand why we are doing this and what's like the purpose of it. So now we just need to make steps towards this. Because what we want to achieve is burning down our tech debt to reduce the number of this file to get it to 0. Here I would suggest a strategy. The strategy looks as the following. Extend the playbook of the developers, tell them, okay, now if you're working in a code space, every time you are creating a new addition, every time you are creating a new class, anything that is new, it is not acceptable that there is any violation of Rubocop. And if you're touching existing code, legacy code, then you can decide for yourself. Developers are clever enough to make the decision to see like, hey, this is an easy change, I will do it, or this will cost me a whole day just to refactor something, so they can decide on their own if they want to tackle this. Which basically means just don't add anything new to the to-do file, in other words. But we need some rules. It's easier to process. But what if the case happens that we never just get anything fixed on the current code base? So we never refactor on changes, and we only take care for the additions. Then we will come up again with this presentation of our visualization, which means no changes at all, no reduction on the to-do lines. But if you look closely, then you see that we have tech debt in there signed as the increasing line, because tech debt is always growing. But as we came up with a strategy how to tackle tech debt for the future, we are already tackling tech debt, which means we have tech debt under control, because we decide what we are going to do, but we certainly ensure that it doesn't grow. So we stop the natural process of it, which is a cool thing. And there's an additional thing to that. Looking at the code, there might be a reason why we don't change the lower part, why we don't change the things that are violated in the existing code. The reason for that is likely because you never make changes to that code, which means like it's running in your product in production, your customer is using it, and it seems there are not enough errors popping up that you have a reason to change it. Which brings me to something that I want to share. We don't need to fix everything. We have tech debt already under control at this point, and we know we have a certain level that we can improve, and it might improve over time. But there is no reason to touch it just for the feeling better. It's just like, leave it as it is, it doesn't break anything. And that concludes it. We are done with the framework. We have identified the number of things that we need to fix. We have an idea how we are doing. We created this vision so everyone on the team, in the company understands why we are doing this. And we have a strategy for actually dealing with this. And the framework has some implications. Let's revisit the terms from the beginning. Let's revisit how it changes our way, how we communicate about tech debt. The first thing is talking about technical debt. The term technical debt is something that I only use when I talk to developers, because it gives a sort of responsibility, and it gives this nice image of, hey, we need to deal with it because there's an interest on it. And if we don't take care, it's our debt to take care, then it will increase. But now talking to the developers, I have so much more information. I understand how much of a problem are we having. We can look at the statistics and we see, hey, we did well in the last months. Maybe we did 50% down of the total file, which is like 50% of our tech debt is solved, which means we can celebrate. And celebration is very important. We also understand why the hell are we doing this. And that's great. And so as everyone understands what is the benefit that we are gaining from it, on your daily work, you will also try to follow this vision and achieve it. There's software rot. And software rot I usually use when I'm talking to technical and non-technical people. Think of a situation where you sit together with a product manager and a team. And here I don't want to say technical debt, because I don't want to give them the feeling that we are responsible for this mess. I want to tell them that this is a natural process. This is rotting away. You know, that like we cannot do anything against it. Also, we are already doing this. We already have it under control. And we can share our vision with the product manager and tell like, hey, if we get some resources to actually work on this, to reduce this, then we gain some benefits. And it's clear to see. And it's easier to talk about this if you also have a history. If you see like, hey, we are doing good, or we are doing not good. We are actually, it increases for some reason. That's also something that you can share with a product manager and tell like, hey, we might slow down even because our tech debt is growing. The last thing, business risk, is something that I would only ever use with non-technical people. This is a perfect candidate when you're talking to the CEO, because this is the kind of situation where I can tell like, hey, we have some outdated dependencies. And you know what? We did some research and we figured that we have, I don't know, 10 unresolved security patches in there. And you can say like the last ones that we fixed were 10 weeks ago, and we are doing bad. And if it goes on like this, then we won't fix them at all. So you have the numbers that you can tell, because CEOs always ask you the first question, how big of a problem do we have? You know, you need the numbers. You also have the vision. You can communicate why are we doing this and why we are spending time on it. But you also can communicate that the team or the developers already are on it and they have a strategy how to keep control of the things. That's nice. One thing that you might wonder is, but there's so many different tech debt. And this framework, it looks so simple because I picked a very simple example for sure. But you can actually use it also very easily. You just need to be very creative how to get to the numbers and how to figure out the vision why you are doing things, which is also a good thing. If you're struggling to build your vision, just don't take care for this tech debt because it's certainly not, doesn't have a reason to tackle it. One very common tech debt is low test coverage. This is also something that I advise you take care of this very, very early because it helps you with any other tech debt that you need to deal with. Low test coverage. Let's say we have 60% of test coverage. We want to increase this test coverage, and I need to say test coverage is a metric. It's a good, it's not a great metric, it's a good enough metric. So if it's low, it gives you a good signal that you need to increase it. If it's high, it's kind of like worthless. We have 60%. We want to achieve 100. 100 is like, also don't go for 100, go for 95. That's more realistic. There's always something in your code base that you just don't want to test because it doesn't make sense. Our realistic goal is 95. In this case, turn it around. Turn it upside down. That means we are not at 60%, we are at missing 40%. And we are again back at our burn down chart. And we also see we can follow the tech debt rule. Because we know if we just don't test, then our test coverage will follow this line. It will get lower and lower because we are doing additions and we are not testing. What we want to achieve is a 95. I think it's even precise how I put the X there. But here again, let's think about the Robocop example. I can do the same strategy. I can say like, okay, we know about the missing test coverage. That's something we want to get rid of because our vision is if we achieve 95%, it gives you a much better feeling and it's much easier to deploy. If you have a test suite that you can trust and it has a proper coverage, then your life is getting so much better with that. So follow the same strategy means on addition, 95% coverage. That's something that should always happen. And if you change some existing code, decide for yourself. Well, we will come up with the same situation. If we never change the existing code, we will end up with something like this. That means the code that is already in place, that is running in production, and that no errors are coming back to the customer support or are coming back to you or popping up in your error monitoring. That means this code is already tested by the customer, which is not a recommendation by mine, but if this is already the case, just leave it and don't fix it, because there's no reason to come up with test coverage for something that is working anyways. Ruby gems. Dependencies, there are a lot of different tools. You can even use bundler to get numbers out of your outdated dependencies. So just get an idea of how much of troubles you are having. I hope that you don't need to figure out how many security patches you are missing. Like, take security patches very serious and keep it always at 0. Replacing a service. We talked about legacy code that you have in your code base. Well, in best case, if you used a service and you no longer want to use it, you should have used an adapter in first place and use this adapter in your code so you can easily swap out which service you're using. But let's say you have not, and there's this legacy service all over the place. You can search for it and you get an idea how many times you need to replace it, or better, replace it with an adapter. We also have heard of strong coupling and low cohesion already. We also heard about backwork a few times today. And Backrack also comes with a to-do file, a to-do generation command, which is also nice. You also get an idea of how many times do I have dependency violations in my code base. That concludes it for my framework. I just want to repeat one time. If you want to apply this, get some numbers, find out a creative way how to get an idea of how much of a problem you're having, keep track of it. So keep visualizations that you can share with every developer, that is easy to understand for every developer. That's why I'm striving for burn-down charts. Everyone understands we need to get at some point at 0. Create a vision. Without the vision, you are doing something that just doesn't make sense. And you need to have a vision to communicate, but also to understand easier why are you doing this every day. And then easily find a strategy to break things into smaller pieces and go step towards this vision. I shared this presentation at the GitHub repository. If you want to discuss about this, I'm super eager to talk about this much, much longer. Thank you very much for your attention.